The theory of relativity. Now, to start with, what is the theory of relativity? The answer to this question is the theory of relativity is a scientific framework proposed by Albert Einstein to describe the relationship between space, time, and gravity. It consists of two main theories. One is special theory of relativity, and another one is general relativity. Now, what is special relativity? Special relativity proposed in 1905 deals with the behavior of objects moving at significant fractions of the speed of light. It introduces concepts like time dilation, length contraction, and the equivalence of mass and energy. The next important question is what is time dilation in special relativity? Now, this time dilation refers to the phenomenon where time appears to move slower for an object in motion relative to an observer at rest. This effect becomes significant as an object approaches the speed of light. Now, for example, a fast-moving astronaut experiences less time compared to a stationary observer on Earth. The next important question is what is length contraction in special relativity? Now, length contraction is the contraction of an object's length in the direction of its motion relative to an observer. As the object approaches the speed of light, its length appears shortened. For example, spacecraft moving near the speed of light appears shorter to a stationary observer. The next important question is now what is the theory of general relativity? Now, this general relativity was proposed in 1915. It extends the principles of special relativity to include gravity in it. It describes gravity as the curvature of space and time that's caused by the mass and energy. Massive objects bend the fabric of space and time, causing objects to move along the curved paths. The next important question is, how does general relativity explain gravitational time dilation? To answer this question, in general relativity, massive objects create curvature in space and time. Clocks placed at different gravitational potentials tick at different rates due to this curvature. Now, for example, clocks on the Earth's surface tick slower than those in the orbit due to the difference in gravitational potential. The next important question is, what is gravitational lensing in general relativity? Now, to answer this question, gravitational lensing is the bending of light around the massive objects such as galaxies or black holes, quasars. This effect results from the curvature of space-time predicted by general relativity. Now, for example, Einstein's cross, where a distant quasar's light is bent into four images by an intervening galaxy's gravity. What is the equivalence principle in general relativity? To answer this question, the equivalence principle states that in small enough regions of space and time, the effects of gravity are indistinguishable from those of acceleration. This principle led Einstein to insight that gravity is not a force, but a curvature of space and time. The next question would be, how was general relativity confirmed during solar eclipse? This solar eclipse was observed in 1919. During a solar eclipse, Arthur Eddington observed that stars near the sun appeared slightly shifted from their usual positions due to the sun's gravity bending light. Now, this confirmed Einstein's prediction of gravitational bending of light and provided strong evidence for general relativity. And to be precise, this general relativity has very profound applications for cosmology and astrophysics. It explains the motion of planets, the bending of light around the massive objects, the expansion of universe, and the existence of black holes.